So I've been running this YouTube channel for a while now, and I realized the other day I haven't actually fixed a Commodore 64, which I'm pretty sure is illegal. So today we're going to rectify that by working on this bread bin that I picked up just recently. Not working, my favorite condition. It also came with a spare mainboard. Who knows? Both not working, both worth a shot. Let's dive into them and see what we get. Rightio, on the bench. Like I said in the intro, I got two boards here, one in the case and one just loose. So let's take a quick look at them, starting with the loose one. Now, as we can see, it is pretty much unpopulated. All of the, the main ICs are missing, including the VIC and even the retimer chip, not the retimer, the timer chip on the clock chip for the VIC. But I can see some odd ICs socketed. There's a couple of RAM that have been replaced here and some of the logic chips. It's kind of weird. Yeah, rework obviously done there. Looks like the 7805's been replaced as well. None of the caps. Oh, we're missing a fuse too. And I have absolutely no idea what to go with this is, but obviously something. Yeah, anyway. Let's take a look at the bread bin. So the bread bin is in decent condition. It doesn't actually have any screws, which is interesting. It does have some just surface blemishes and a little bit of dirt. We've got some of the scissors markings from where like the cable has been sitting inside the foam, the packaging, and it's that interaction between the ABS plastic and the cable, and it kind of melts it. Yeah, there's some more there, a little bit more intense, where it actually just kind of melts through, and there's really nothing you can do about that other than just kind of try to scratch it back and level it out as much as possible. This is made in England. That's interesting. So let's take a look inside. Like I said, screws are missing, and keyboard is actually detached. But there's the LED, and we've got the RF shield, which we don't really care about, so we'll probably just be getting rid of that. This board is also not screwed down, I can see, so that's just loose. Let's just take that out. Yeah, leave the RF shield in place. Alright, let's see what we got on this board. Okay, so we've got our VIC and our clock chip. We've got a SID, which is interesting, but no PLA. We've got a CPU. We have the kernel and basic, but no character ROM, and we don't have any CIAs. We do have a fuse, however, so that's nice. Still all the original capacitors, so it hasn't been recapped, and none of the RAM. These Oki RAM are still in place, so none of that has been replaced. Nothing dangerous looking, although I can see an MOS logic chip there, which always signals disaster. Oh, I can also see, just at a glance, I just noticed this. There's a big, I don't know if that's going to come through on the camera. Zoom down a touch. Huge scratch on the board. So that's interesting. I might have to, verify whether that's causing a problem, whether any of those traces are broken or it's just a superficial scratch. What about the back? I can see a little bit of rework done here. What's that for? That is this 74LS 139 U15. Not quite sure what that is off the top of my head. A bit of a scratch on the PCB over here. That does immediately just look superficial. This is the keyboard connector cables, it looks like. Goes up to, yeah. These lines all go up to the keyboard connector, so we'll have to check if the keyboard's working for that as well. Otherwise, the board is in pretty good condition. It's just a little bit dirty, but we can fix that later. Let's get it tested. So to start with, I do have the power. I've got my video. I've also grabbed my good bread bin and opened it up, ready for donating some of its components as need be. So for this one, I'm probably not going to grab anything because I do have some spare PLAs. Don't necessarily need a character ROM to check, or the CIAs even, to check that it's mostly working. We can just kind of see, the basic function. We want to check that the CPU's working, we want to check that the VIC's working, and that the board in general, doesn't have any glaring faults, doesn't blow the fuse when you plug it in or anything like that. Got my IC sheet off to the side here, so this is my, Commodore 64 components. So I've got some bad stuff down here, and these are my good working ones. I've got an actual PLA, and I've got some of these modern replacement. These are the XC PLAs by Hackup. Yeah, so let's pop one of those in. U17 here. Now, I've also got my Kung Fu Flash with the active cart. I set this up earlier on my regular, my working system. I've got it set up on the diagnostics cart. So if we do boot, we'll be able to see what we get. Let's hit power and see what we get. We've got power. Oh, okay. So we are getting the diagnostics. Now, the horrible characters is because I don't have a character ROM in. That's pretty standard. Let's just see. It looks like it's doing stuff, so that's executing some kind of test. I think it's the RAM tests, maybe? What are we doing now? Okay, well, it's marked something as bad. Oh, and you can see it scanning. That's doing the color RAM test, where it scans each line individually. So it looks like, I mean, that tells me the VIC and the CPU are working fine. It's marked a whole bunch of stuff as bad. But interestingly, none of the RAM... So the RAM would be down in the box down there. Should say. Oh. It's doing the SID test. Well, that sounds bad. Yeah, okay. So that would be why the SID is included, because it's crap. Yeah, normally you would not see a SID included in the board because they're pretty worth... They're worth a lot of money if they're still working, and this one is not. So that would be why that was included. Huh. And then, yeah, it looks like it's looping. Interesting. Okay. So... Alright, let's flick that off. Yeah, it's looping again, so there's the color RAM test again. Cool, okay. Well, let's... like I said, I've got my good bread bin. Let's harvest some parts. Let's grab the character ROM and the 2 CIAs, pump them in, and see what we get. Now, I could do this the other way, move these components over, but like I said, the board already looks like it's working because, you know, we're getting the screen of the diagnostics ROM, and it's obviously running tests, so I trust that this board is generally okay, and I just want to check the rest of the stuff. So we've got CIAs, we've got our character ROM, we've got a full complement now. Let's flick it on again and see what we get now. Oh, okay. Well, that's a lot more stable, but those are the wrong characters. So that's not good. Still something wrong. Let's see if it runs through the tests. Yep. Yeah, there it's doing test things. Ah. That's interesting. So it looks like... I'm pretty sure that's the running the RAM tests. So it looks like when it runs through the RAM tests, it... Yeah, there's the color ROM. It changes what character is displayed. It's strange. Well, yeah, now that we've got the 2 CIAs, it's looking a lot better. And there's the horrible SID test again. What about the regular, just basic screen? Right, yeah. So we get a good screen, which means the kernel's possibly okay. No, we're not getting the text that you'd normally get displayed at the top if the character ROM was it bad. So, without doing any further testing, my immediate suspicion goes to this MOS chip. Actually, I didn't check if we've got anything heating up, so let's do that really quickly. Okay. Well, the SID always warms up. That's fine. Just the old finger test. And no, everything seems normal. I'm immediately drawn to the MOS because the MOS logic chips, so this is a MOS 7709. I did print out the schematics for this board assembly here, the 250425, which is the schematic number 251469. This is U14, which is 350 U14. Here it is. So that these MOS chips were logic chips that so they're pretty much typically just plain 7.4 logic that MOS produced in-house because they had the capability and ended up being cheaper, but they pretty much are known to fail they're not the most robust ICs. And if you look at the schematic here, it does say U14 and it is a 74LS258. So we could replace that, but like I said, I haven't tested anything. Let's check what that's doing. So I am going to boot up my oscilloscope and let's see if we get any bad logic levels on that. Alrighty, so here we are. We've got the 74258 datasheet up, and we're taking a look at what we have here. So it is a quadruple 2-line to 1-line data selector / multiplexer. So that tells me is that has 4 sets of data selectors, which is 2 pins in and 1 pin out. So that'll be an A and a B in and a Y out on the datasheet. And then there'll be a selector pin, which is the A/B. It's in pin 1 up there, which is active low is A and then active high is B. So when that pin 1 is driven low, that is active low, which is the A. That means that whatever data or whatever signal is coming in on the A pin will go out to the Y pin in the same set. So if you have a look at pins 2, 3, 4 there, you got 1A, 1B and 1Y. So like I said, if we're driving 1 low, the whatever's coming in on 2 will go out on pin 4. And if we're driving pin 1 high, which is B, whatever's coming in on pin 3, 1B, will go out for 1Y. That also is determined by the chip select, or the G pin there. That's on pin 15. So if that's, you can tell by the little bar across it, that is also active low, which means for the chip to actually be enabled, that pin 15 has to be driven down to ground. So if that is not sitting at ground, if that's high, doesn't matter what A or B is, the output to all of the Y pins will also be, I think it's, well, let's have a look. It should be down the bottom here. So yeah, output control there, high. So if it is high, so it doesn't matter. That's what X, irrelevant. Select line is X, A and B is X. The output is high impedance. So it's connected to nothing effectively. So let's check some things. First of all, just got to check voltages. Pretty straightforward. Make sure on pin 16 up here we have 5 volts on the scope. And we do. So that's, yeah, 4.89. That's fine. Close enough. Then let's check that chip select. So that's on pin 15. With that one right there. And yeah, looks fine. So that's going up, coming down. It's not as high as I'd expect. Only topping out at 3.68 volts. I want to see that closer to VCC, up to that 4.88. But it is coming down to ground, which does mean that the chip is being selected to gather its outputs, so that's fine. And then let's check that AB, this the data select pin, which is on pin 1 up here, and we also want to see that that's going up and down as the different lines are being selected. Yeah, so that looks fine as well. Though we're also only seeing that going up to that 3.6, 3.7 volts, so not great, but it is doing stuff. Well, let's have a look at that line 1. So pins 2, 3, and 4. So 2 and 3 will be the input, and pin 4 will be the output. So let's check pin 2 for the input of A, and it seems to just be constantly high. And the B does kind of have a signal on it. That's not really great. Let's see what the output looks like. And the output doesn't really look anything like those. Kind of looks, I mean, that would be, I kind of need two lines here, one on the select and one on the data, but I'm more curious as to why this, that's not good. So that's the B input, and it looks frankly terrible. Okay. What I'm going to do, just as an example, is I'm going to grab my good bread bin that I just took these out of, pop these chips back in, and check what our U14, which is here in this revision, there it is, 74LS258, and that's a real Texas Instruments part. Let's just see what those signals look like on a, good working board. So let's do that. Alrighty, let's just first of all verify that we do have power and it's switching on. Yep, there we go. Nice boot screen. I don't have the keyboard in, but here we are. And like I said, let's take a look at those pins. So we are looking for, I think it was pin 5 and pin 2. So that's straight up to 5 volts, which looks good. Booted. Pin 5. Also straight up to 5 volts, looks really good. And you can see there that says, you know, an average of top of 5.2 volts, which is a far cry from the low voltage that we were seeing before. So this is pin 4, and it looks okay. We've got, what's that? We've got 1 volt per division, so there's 3.5 to 4.5-ish, or 4 and a bit volts. It's not too bad. Still not great, but we are looking at the combination of 1, which is high, that A and B, which should look like that, and then we've got the switching of there and the switching of the output enable, all having to line up to get us this output signal, which is kind of flowing. Let's have a power cycle, and you can see that's kind of doing work while the system's booting up, and then it will stabilize in this regular pattern. Let's check this again. So we are looking for a combination of this, which is high, this, which is not as vigorously bouncing as it was before, and we are getting this similar looking pattern. Let's watch that as it boots up again. And it's not kind of doing as much work as it was previously, which is interesting. It's not quite the smoking gun I was looking for. To be honest, let's, I reckon, take a look at the character ROM, I suppose, because, well, we were seeing, obviously, the character data looking all messed up. So let's see that we're actually getting the correct pin out and input signals to and from the character ROM. So I'm still leaning towards this MOS chip, even though I can't really prove out that it's not looking good without doing a lot more work. I'd have to set up multiple scope probes and triggers, and I think let's just remove it. Now, what to replace it with? I could take the one out of my working 64 and plug that in. I really don't want to do that though. If it's working in there, so be it. Got this other board that we could try. It has U14 right there. That is a very old, it's the I can't remember the manufacturer, but that is the 74LS258 APC. And this board looks like it's in a state, so I don't feel that bad about taking it off this one. There's no rework on it, so hasn't been touched. Possibly what we'll do instead, let's stop working on this board. Let's migrate all these over to this and see what's wrong on this board, if anything. Let's try that first. Oh, let's just make sure that that is U17, and yes, it is correct. Okay. Some revisions of the boards, although these are the same revision, the 250425. Some revisions have the SID and the U17, the PLA, backwards. We're in for a bad time. And last but not least, our fuse. Let's make sure we power it off. Video and power. Let's see what we get. Nothing. A whole bunch of nothing. Alright, let's try the diagnostic. Now, I don't have a dead test cart at the moment, just the Kung Fu Flash. I should probably find mine. I've lost my Versa cart somewhere. Yeah, let's see if the diagnostics boots up. That's a big fat no. That sucks. Okay. Well, the right chips are getting warm. Ooh. Yeah, that's our color RAM. Scaldingly hot. Okay. Interesting. Are we getting 5 volts correctly? Yeah, we got a perfect 5 volts out. I've never known a failed color RAM to completely black screen a C64. Normally you would get it working, but it'd just be corrupted image, especially on the thingy. Possibly if I ran the dead test cart, we'd get something. Flashings of some variety. But, like I said, I don't have it available right now, so it is what it is. I wonder why all of these other ICs were replaced, but not the color RAM by whoever's worked on this in the past. Well, yeah, I can't really do much about that right now. But it does look like we've got 2 boards that individually have separate issues that could do with some swapping. So what I'm going to probably do is, let's take the color RAM off the first board here and swap it into the color RAM on this board here, and we'll see if we can bring this board back, and if so, we can swap out the 258 onto this board and see if we can get that board, you know, swap the color RAM back and see if we can get this board working. And then if those are the 2 problems, then we have 2 working boards. We just need to get a couple of replacements, but if not, we can continue diagnosing more problems. Yeah, it sounds like a plan. Alright, let me fire everything up, get to work. Looks like we've still got some solder on the top side, so what I'm going to do is use some hot air and some lifting. This is the way I always recommend taking chips off of Commodore 64 boards, because otherwise you can pull up the traces really easily. Got most of the solder out. Now I'll heat that area really gently with the cheap soldering, the cheap hot air station, and not pry, just let it lift up. And then it'll just start coming loose. And there we go. No lifted pads. Pin safely out. And we'll do the same for the 7.4 there. Let's just get that PLA out of the way. Actually, what I'm going to do just before, because we have a socket nearby, I'm going to put a little bit of Kapton down just to protect that plastic. And so that should allow the heat to just skip over. There. And I'll also aim away. There we go. Also that. Beautiful. 2 trips extracted. No pull pads. Nice clean holes. What more could you want? Alright, let's get some sockets in. Oof. And I'm low. It's good that I've got one more left, because I'm going to be doing the same thing on the other board. Goes out. Order some more 18 ways. Beautiful. Alright. Let's do the old rinser repeater. Okay, there we go. 2 boards with extracted chips and new sockets. So, let's get the other board back, which is the one that already has all of the parts available. Plug our power in, make sure we're powered off. Video. Let's put the PLA back in. Let's put the 7.4 logic back in its spot. And let's put the color ROM from the good board, well, the better board, in here. Great. And let's see what we get. So this was the black board with the burning up color ROM before. Color RAM, I should say. Still a black screen. And is our color RAM is cold now though. Yeah, okay. Let's see what we get for video diagnostics. Also nothing. Yeah, I think I'm going to need a dead test one for this. I think this board's going to be a little bit more involved for now. So let's go back to the other board that looked like it had a relatively simple problem. Okay, so this was the board with the MOS 7709. That's the 74258. So let's pop in the 74258 that we got from the other board into the U14 slot, and let's try the bad color RAM, the one that we thought was bad from the other board as well, and maybe we can prove that it is actually good. So yeah, maybe the color RAM is fine. Who knows? Guess we'll find out. Alright. Power. Video. Let's see what screen we get. Ah. Got the fuse. Okay. Now let's see what video we get. Hey. Ooh. Almost. It's slightly off. I think that color RAM is still bad, because that color is wrong. But looking pretty good. Let's get the diagnostics out and run that up. Yeah, look at that. Screen RAM testing. So, I mean, this is already immediately better. So it is clear that this MOS logic chip was the cause of all of that character ROM problem. It's the RAM test. Looks good. RAM test 2. Taking a while. Also, and oh, PLA test bad. Color RAM, and you can see that there's no scanning. So that tells me the color RAM is bad. Okay, so I'm just going to turn that off. And let's swap the original color RAM that was in this mainboard back in, which is this one. And let's give that another try. Yeah, there you go. Perfect colors. Ha! Yeah, and then you can see the color RAM testing. The PLA test has come back happy now. So it was clearly just the color RAM bad. I keep saying ROM. Ooh, kernel ROM, and it reads them. Yep, that's great. And yeah, I don't have the harness, so it's not testing any of the ports. Also don't have the SID plugged in, so the sound's not there. Those bads are expected without the harness plugged in. That looks fantastic. Yeah, that's perfect. So let's see if we can go back out to the menu, which we can. I don't have the keyboard plugged in though, but even the Kung Fu Flash menu is working there. So that's, yeah, I'm really happy with that. That looks like one pretty much repaired C64. So here's the list of things that we're going to need for it. Need a SID. We need 2 CIAs, because both of those are out of the borrowed. We need a character ROM. Thankfully, the character ROM, I can just use a converter, so like a memory chip converter and flash my own 2732 or 2764 with the character ROM in there and place that in the board. So we don't actually need a real character ROM. And we're going to need a 74258 replacement because I've borrowed that one as well. Now I do have a couple of CIAs here, but I noticed, I do remember the last time I tried using one of these, this one is missing a pin there, so I'm pretty sure that's one of the IRQ pins, which is necessary. So I might try and repair that, possibly in another video, because that's a process in itself. Might even see if I can get one of those new JCIAs, the FPGA replacement one. I don't know if they're even out properly yet. I haven't looked at that project in a while. So the main culprit was this MOS 7709 logic chip. You know what we can do as well? Double check. I do have my retro chip tester here. Alright, so here's our retro chip tester. We'll pop the 7 in. I'm going to go to logic. From logic. So we are looking for 74. Let's go backwards. So 258. 74258. Let's give it a shot. There you go. Yep, failed. So yes, this multiplexer 2-to-1 line selector and multiplexer is indeed bad. That sucks. Now I'm going to probably leave this board for another video because that looks like a much bigger repair, and I'm going to have to get some more. First of all, I'm going to need some more color RAM, and I'm going to need some more 258s, so I'll probably order both of those now and see where we get to with that. And then take a dive. Maybe I'll see about finding some more everything, because I'm going to need a new CPU, I need some more everything else. It's going to be a mess. Figure it out. So it's been about a week since we last looked at this unit. Been a bit busy with work, day job and all, but finally getting back to it now tonight. And what I did was I have popped in one of the SIDs that I had on my little sheet here. I had two up there. This one and the other one. Now this one, actually both of them, they both got a little green check on there because when I put them away, they were working fine. This one doesn't work at all anymore, so that's just what's happening with SIDs. They are just sitting there and eventually died. This one passes the dead test, which I'll run up here. So the other one, if I pop it in, it just makes a brrr sound terrible. This one will actually run through the sound test just fine. So let's let it do that really quickly. Kind of missing a voice there, aren't we? So what I noticed, and if I run up the game, burn and rubber here, so this is what I saw. Did you hear that? Let me reset and we'll check it again. Music just stops, which is a bit of a bummer. The other thing that I noticed, I grabbed my controller here. So this is the NES controller that I have converted to be a Commodore 64 using an Arduino microcontroller. Link up in the whatever. But if we plug that in, turn it on, start up Burn and Rubber, it says, lose the sound, but it says use joystick or keys. But joystick no working. And I know this works. Connected this to my C64C with Burn and Rubber. Sound works great. Joystick works great. So multiple problems still. Don't have a working SID. And, well, for some reason, joystick port's not working either. So we need to figure that out. First and foremost, what I'm going to do is I'm just going to try and swap out the SID with the one from my other breadbin C64. So it kind of sucks that both of the good SIDs that I had sitting there are now dead, but it is what it is. There's my breadbin, poached for parts already. Alright, now let's just flick it on and see if we get sound. Yeah, so that's what Burn and Rubber should sound like. Well, that's just disappointing. Okay. Well, let's leave the poached chip in place and try to figure out what is going on with our joystick port.
One eternity later.
Right, so after a bunch of tracing, couldn't find anything wrong with this board. The joystick lines seemed fine, they went straight to the CIAs, which leads me to the CIAs. So I popped everything back in my original bread bin, my good one. First of all, found that my old XC PLA had died, so just swapped over the PLA as well, and I'm exhibiting the same joystick problem in here. If we flick it on, Burn Rubber, nothing. So, looks like I've got a CIA problem more than anything. So what I'll do is I'll just, first of all, swap the CIAs around. Let's see if one of them is at fault rather than both of them. Because I don't know which one specifically handles joystick. I just don't. I'm sure it's documented somewhere. I couldn't tell you without looking it up. Alright. Now let's try. Neither. Alright, both still a problem. Which is not good. It means I don't have a good CIA. Okay, let's try. I do have these two spare CIAs, one with the missing pin, but let's try one of those. Let's try this one, because I think this one does more joystick, just based on the traces that I was looking at. No. Still nada. Alright. Swap them around too. Still nothing. Okay. Last try. Swap this other with this one. Here goes. No. That sucks. Ah. Damn. Alright. Absolute Hail Mary. Let's try the one with the missing pin. Who knows? Maybe we'll get lucky. And it doesn't need the interrupt line. Oh, I don't have sound. No, the game's not progressing at all. Just for a sanity check. Oh, you bugger. This was working. Oh, come on. Really? Really? You're gonna do this to me? Ah. Let me go find another joystick. Alright, had to dig into storage for this bad boy, but we have an original Commodore joystick. So, yeah, look at that, made in Hong Kong. Let's give it a try. No smarts. Just joystick. Hey, look at that. Okay. Yep. All directions work. Reach speed. Can we jump? Yes, we can jump. Okay. now we can test. Alright. We've got the character ROM in there. We've got our PLA is on the bottom on this board. That is U17, and the SID lives on top. Do not mix them up, because you will explode your SID. Okay. Cartridge in. Video in. Power. Rudimentary joystick. Let's go. Okay. It works fine. So I don't have the keyboard connected, so I can't press F1. So let's do that really quickly. Alright. Yeah. Love this game. Ah! Oh, can you land? Ah, missed him. So yeah, it's working fine. Oh no. Dangerous move. Worked out. Oh, not too slow. There we go. This is my pretty much all-time favourite C64 SID track. Just, I love it. Whoa. Oh. Never said I was good at this game. I just like it. Oh! Alright, well, it works. So I'm going to get this back together as a single unit. Yeah, while I'm doing this, I might just cover over what we did. So with this unit in particular, mostly it was the logic chip here, the MOS 7709, I think it was. It's one of these ones over here. Oh, one there. Yeah, 7709. So that I replaced with the, what is it, 74258 from my other mainboard here, which seemed to work. It's now booting just fine, but it does mean that our other mainboard is without that logic chip as well, so I'm going to have to get another one. I will order some parts for that. We also were missing the, the character ROM, which is pretty important. You know, makes characters on the screen appear. Very important. We were missing the PAL and the SID, sorry, the PLA and the SID. So the PLA I've replaced with that XC PLA, and that can live in there. I've got a handful of those spare. The SID I borrowed from my other bread bin, so I'm going to have to get a SID replacement because I do not have a working. I thought I had two working ones. Neither of them work well. So I'm going to have to get a replacement SID. I think I will look at making some Swin SIDs. Alternatively, I could order a ARM SID. ARM SID would be best for compatibility. It's the one that sounds the most accurate, I guess. And the other ones were the CAA, but these ones seem to be working fine, even though we're missing that interrupt pins. But I could just repair that, and I think that's what I'll do. I don't think I'll dedicate an entire video to that. I might make a short. It'll show up in the channel sometime soon. This is pretty much back together and working great. I'm really happy with how it's turned out. I'll leave those borrowed chips in there for the time being, but I will obviously need to be getting those out and replacing them with, you know, new parts at some point in time. But that's not going to happen today. For now, though, I think I'll close this video out. And in the next part, which there will be a next part, I will be tackling the other mainboard that I've got there, the the other bread bin mainboard. I'll probably have to crack this guy open again and take those parts back out so that I can get that one tested and working again. And then I'll eventually need to get my main Commodore 64, my bread bin, back and working again as well. But the one thing that I did need for this mainboard in particular that I am without at the moment, and I can't really progress without, I could, but it's a lot easier without, is a dead test cart. Like I said, I couldn't figure out how to get the dead test working on the Kung Fu Flash. It is supposed to support it, and it is supposed to support Ultimax mode, but for some reason it just refuses to start. So I'll need to make I'll get a Versa card or make one of the I think they're called the Open 64 card or Open Card 64, something like that. It's a open source equivalent. But yeah, this was our main goal for this one, and got it going. Thanks for watching.